Well, we've heard from farmers, we've heard from vets about how we can improve the use of antibiotics. So now I'll give the floor to the labs and the scientists, and they will present their contribution to efforts to tackle AMR. So this session will be co-chaired by Mrs. Ariane van der Stappen and Mr. Dean Bosniak from the Commission's Medicinal Product Unit. I'll give you the floor.
Merci et bonjour à tous. Donc dans la...
Well, thank you and morning everyone. Taking account of our discussions so far and the point made about veterinary specialists' responsibilities and how they can meet those as best as possible, but also the need for a good database. But in general terms, we also need qualitative working instruments, and that's why this last morning session's well timed, because we're going to be talking about exactly just those things. It's about improving for the future so that we can target better these particular antibiotics. I must say it's a particular pleasure for me to be able to welcome to our meeting Dr. Marc Saumon, who is a veterinary specialist working in a French private veterinary cabinet specialising in agriculture since 2003, responsible for the pathology services in the regional animal disease specialist services in France. And Dr. Saumon is going to give us the latest developments, latest results in rapid testing. But in addition, he's going to tell us about how these recent developments can help us in the battle against AMR. And that's, of course, a point of focus right through all these discussions this morning and today. So thank you, Dr. Saumon. Mr. Saumon, thank you. Morning, everyone. Just in these few slides, there's very limited time. We're going to tell you about our work in laboratories, in microbiology, in combating AMR. Our technologies basically have two arms to them, very straightforward. Firstly, it's based on proper identification as soon as possible of the pathogenic bacteria or the bacteria relevant to the particular case of animal pathology. Secondly, as a result of the first aspect, it's to make available information as exact as possible, as soon as possible, about the resistance profile of this particular bacteria. This raises three particular requirements of the client concerned. Firstly, reliable results. Well, that goes without saying. Secondly, as soon as possible. Given modern contemporary situations, we know that time wasted means that results are pointless or watered down in value very seriously. And also, good value, not too expensive. We represent about 2,000 in the herd in our work compared with other laboratories which are much bigger. Maybe that doesn't sound as if we have a lot, but notwithstanding that, we have a number of problems. Lack of specific technological developments in the veterinary area, apart from maybe PCR. Also, very limited level of automation, which, if there was more, cuts down costs and also speeds up the provision and working out of the results. Automation important there. Also, we suffer in our part of the world from a lack of properly sorted out networks. That's because Belgium's not such a big country, so maybe something to do with the scale. Some very simple things, straightforward. On a prior basis, the classic phenotypical tests, biochemical, that type of thing. Recently, going back to 2003, we, in the wake of that period, developed spectrometry, mass spectrometry, very relevant to Mal-de-Toff, using proteins to identify the bacteria. That mass spectrometry using Mal-de-Toff, what a revolution that's been. Speeded up results immensely. Then also We sow in the different types of cultivation. We use the basic cultivation types where we wish to standardize types. That's common to all types of bacteriology right up to now and was used in the old days. But apart from this first sowing, there are other things we have to do, such as coloration tests, phenotypical tests, coloration, oxidasis, catalysis, etc. And that then will be followed up within 24 or 48 hours by other tests which will delay identifications of any results. Now that's the situation hitherto. But thanks to the Malditoff mass spectrometry, we've been able to do away with that 48-hour link. It takes 2 hours following the 24-hour period of initial incubation, only 2 hours using Malditoff to identify the bacteriology. That's how much it speeded up. So how does that affect the speed with which we were able to provide results in our laboratory? Well, look for yourselves, 2012, we didn't have the equipment, even though the work level was going up very, very much in terms of the bacteriological effort and concerns we had, which meant that there was a critical delay in providing results. Looking at 2012, 30% of results made available over a 2-day period only. 2013, Malditoff came along, first half of 2013. Look at the difference. We went from the 20% critical threshold in the first half of 2013 to 60% in the first 2 days in the fourth quarter of 2013. So you can see that increase there in speed. 2014, another increase because we were able to build up over time, as you'll see there, and it got even better in 2015. This picking up of speed, effectiveness, was because of the improvement in the communication of results via Malditoff, and that means better information systems as well. I think that what this shows is that 30% over 2 days in 2012 to over 92% in 2 days in 2015. That is only 3 years. 30 to 92%. That benefits everybody right through the sector, from veterinary specialists, laboratories, practitioners, farmers, everybody. This is so important, and we think that's pretty significant process over the 3 years. What is Malditoff? Well, it speeds up results. That's a crucial aspect of this instrument, of course, this tool we have. But more than that, what Malditoff does is make more exact the results. It's more sensitive, this particular testing. These laboratory results have more than 4,200 reference spectra available. For example, identifying SCN or microplasma in bovine animals, big improvements there. Regular updates of the archives are now possible as well, which wasn't the case before. That's thanks to Malditoff. But also, we're able now to operate within user networks involving farmers, operators, as well as veterinary services. It means we've got greater access to research results. It means we're cutting down cost, and the yield level of our investments is much higher. The majority of costs using Malditoff actually is the initial investment, which is basically paying for the equipment, but it pays itself off over time very, very effectively. That was the first responsibility of the microbiological laboratory. Second, it's defining the resistance profile of the AMR, antibacterial resistance. Well, we need a proper technology which is available, which works effectively in communicating its results. Subject to accreditation on enterobacterial standards and Staphylococcus aureus. We're talking here about proper testing of the antibiotics. When you use semi-automatic data known as the scanner 2000, here's a picture of it. what you can do, what it facilitates, well, firstly, is the feeding out of raw or general data, the raw data, which then has to be interpreted, and as such is then passed on to the veterinary specialist, who's the first person that we communicate our results to. The link with the veterinary specialist is really important, because passing on those results to the breeder or to the farmer is very, very important responsibility of the veterinary specialist, and then leading to the management policy installed or set up. That's the really priority for the laboratory. Bacteriological results and antibacterial resistance results available in practical terms where it matters, which is amongst the farms. That's what we've got to do. So we've been using that particular machinery for about 14 years or so. It means that we've now got a very good infrastructure, and we feed in our results to a number of different databases so that we can manage our therapies, make widely available this information, both to the public authorities as well as breeders, as well as to farmers concerned. This second objective is the proper use of data. That's our second priority. We've accumulated this research over many years. It's to do with epidemiology and surveillance policies, an ongoing effort. We do understand that our work concerns different types of strains. We don't actually take the sample. It's the veterinary specialist who does that in the farm. We have to understand these preconditions for our work. We often use strains which come from therapeutic waste or residues. We work with the results of autopsies, for example. Fair enough. So the selection takes place on a prior basis. And that is not characteristic of environmental studies generally, the way they're conducted. But this is something that develops over time, and year on year or on a pluriannual, multi-annual basis, we are able to look over our data to see, we think, verifiable trends. And as a result of that, we can verify data coming from the local area. On that basis, we can appraise the work of farmers and veterinary surgeons. And we do believe that the farmers themselves are becoming more and more sensitive and more cautious about the results and the use, practically speaking, of data, which is the produce of their own work after all. Then abstract data which may be handed over to them from an archive or accumulated research, even though they would assert themselves as being more empirical. That may not be felt to be actually the case by the farmer. We produce reports on a regular basis now where we analyse, we compile, we collate, we try to see an overview of the trends in the field of AMR amongst our holdings, amongst our production holdings, but this is exclusively bovine production. That's the context of Belgium. It's basically the only type of herd of any significance, bovine holdings, bovine operations. So we've now reached the fourth edition of this collation, 2015. We're looking forward to 2016 already, and people are asking us when the fifth edition will be available. The reason, or what this shows, is that if there's people who are already knocking on our door, they're interested in this document, people out there in Belgium, across the country want to know about this data. When we first started publishing these early annuals or handbooks, there wasn't so much interest. We had to knock on the door to give people these. But now there's a real awareness of the importance of this. We operate, therefore, through distribution channels, our specialist Objective Dairy network and all the other networks that we use. All these are channels for distribution. We try to get out as many copies as effectively as we can, far and wide. Now, I want to be modest. We have to be modest in our relationships, our communications with our breeders. But for example, here are some E. coli septicemia deaths amongst veal calves, amongst calves there. You can see antibiotic resistance profiles 2005 to 2009, going to 2010 to 2012, and then 2013-15, 3 different schedules there to compare what's happening. Look at the details of all that. You'll see that comparing 2005-9 to 2010-12, then the majority of the antibiotics were subject to quite significant levels of resistance, irrespective of the classification of the antibiotics according to the classification rules or hierarchy. Look, that's Belgium bit there for yellow, in yellow, orange or red. Same exercise done also for 2010, 2012, 2013, 2015. I didn't mean 2010, 2012 increase of resistance for these 2 types, these 2 serotypes there. Gentamicin, first generation. For the first time, we've seen significant resistances in resistance, particularly for tetracycline and phenicoli. So these slides, I think, speak for themselves. If you also deconstruct the period 2013 to 2015, you'll see also for the 3rd and 4th generation of fluorphenicoli, you'll see some levelling off, basically. So things not going up there in that period, 2013-15, things not going down, a levelling off for resistance levels. Some new developments, emerging developments, studies on environmental enterobacteria. Well, not revealed in Belgian studies as such so far, but in bovine, what we did see is coli resistance levels, resistant to colistin, relatively new development. We identified 1 or 2 different resistant strains confirmed in relation to colistin using the Geloses parameter. The first cases of resistance there to the colistin 2012 exponential explosion there, 4.32% now for colistin in bovine production. That was just an example of the sort of work we're doing really at the micro level. We collate all this data on toxology, bacteriology, information on treatment. We compile information on the animals that are looked at, treated, and then it's all compiled so that our expert veterinary advisors are able to draw easily and practically have available to them the information which makes sense, which they can communicate to local farmers and people that can actually use it in practice. So this is really important. Part of this is complying with the usage of antibiotics recommendations which have been drawn up at the international level, at the Belgian level as well. We've got to comply with those recommendations. That's another guideline for us. We're partners to a number of different operators in the sector interested in production and health considerations. We have these platforms for the collection of data so that we can better manage bacteriological aspects. So these platforms we have are all about the better collation of data so that we can get better with AMR, but also so that we can produce better information either via official platforms which exist, such as that one over there, Sanitel Med, also better management of antibacterial resistance databases. So these databases are fed into from the laboratories such as the ones I've just been talking about. Identification of animal data is dealt with in another project over there. That one's just up there. It's the Desire project. And then data from the sector as a whole, whether breeders or veterinary experts. And if you follow that other arrow just in the left, we can avoid double, triple coding. So this slide is basically showing that what we've got to do is simplify as far as possible the recognition of data, the identification of data at the local level. That will have knock-on effects throughout this sector and benefit the work of all the people involved in this chain of command. Thank you.
Okay, thank you very much. Now we will move to another support tool. It's about data collection. The need to collect reliable and comparable data on the sales and use of veterinary antimicrobials has been largely recognized. As already mentioned by Koen van Dijk in Europe, this is currently under the SVAC project on a voluntary basis. And the number of participating countries, 26 at the moment, clearly shows the importance they attribute to this issue. However, we also know currently data on sales rather than use are being collected, and these monitoring systems would need to be upgraded to include also data on actual use, broken down per species, per production systems, weight class, and so on. Today we already heard about the Dutch example, and I would like to invite now Dr. Martin Traufler to present the Austrian example on data collection systems and the research project on antimicrobial consumption in livestock. Dr. Traufler is a Luxembourgish national who completed her graduate and doctoral studies at the University of Veterinary Medicine in Vienna. Her doctoral thesis dealt with quantification of antimicrobial consumption in Austrian pig farms. And since 2015, she holds a postdoctoral position as a researcher at that university and is currently working in the field of antimicrobial consumption in livestock sector. So, Dr. Traufler, please.
Okay, is it working? Yeah, thank you very much, Mr. Chairman, for the kind introduction. Ladies and gentlemen, my presentation is like the previous presentation in the session about support tools for reducing antimicrobial use, and I would like to show to you how actually a data collection system can be a support tool. That's the content of my presentation. I would like to shortly introduce to you the quite new antimicrobial data collection system in Austria, and then I would like to show you by an example of a research project how we can use some specific results and some specific graphics out of this project to use fewer antimicrobials in a better way in the future. And then, of course, I will end with a conclusion. So the Austrian system, it is very new, and it is based on a regulation which is called in German Veterinär-Antibiotika-Mengenströme-Verordnung. So that veterinary antimicrobial flow regulation is actually not an official name, but it's my own translation. And the system is based on the three levels when you're looking at the path of a drug product. It's from the pharmaceutical industry to the veterinary pharmacy. We have in Austria the system that veterinarians have to officially register a veterinary pharmacy in order to get the right to buy and to sell antibiotics. So that's the wholesale level. And then we have the retail level from the vet pharmacy to the farm. And we have, of course, then at the animal level, the use level. And the regulation now requires a compulsory record and an annually data transmission for the wholesale and for the retail level, while the usage level will be voluntary. That's why I use these different colors here. And yeah, of course, wholesale figures will go to the European Surveillance of Veterinary Antimicrobial Consumption project, and the retail level will finally give us in Austria the possibility to evaluate antimicrobial consumption at a species level and even at the farm level, because it will include the information how many antibiotics from what veterinary pharmacy are going to what farm. As I told you, it is very new, so we don't have the data for the retail level yet. They will arrive next year in 2016. And actually for the usage level, we have already at this moment 100% coverage in the poultry sector, and we hope, of course, that the cattle and pig sector will follow suit. So now we must ask ourselves, where is the support of such a system? It is very expensive and it requires a lot of work. So where are the benefits? And I would really like to show you some results from Austria at the national level, but as I told you, we don't have the data yet. And that's why I'm using a project of my doctoral work, which I finished actually not long ago. It's about antimicrobial drug use in Austrian pig farms, and I will show you some specific graphics and figures to show you how we can use them to reduce antimicrobial use. Just to briefly explain to you the project, it was a retrospective data analysis. The farmer, or in some individual cases, the veterinarians recorded the data. We have a use level, so at the farm level. We had 75 conventional pig farms, and the treatments were categorized according to the active substance administration form related to the ATC vet code from the WHO. And we had also the information about for what indication the treatments happened. Antimicrobial use was then expressed in the units, milligram per kilogram, and number of daily doses, which is actually also a very important point, but I would like to come to that later. So here we have the first result. It's antimicrobial use at the farm level. We have ferret-finish, fattening and breeding farms in 4 years, from 2008 to 2011. And we could, for example, look at this median value. It's in fattening farms in 2008. We see that a bit more than 2 animal daily doses per kilogram per year have been used. That means that on average in 1 year, a bit more than every pig is treated a bit longer than 2 days. So where is the support from this graphic? First, we can look at the year. We can make time trend analysis, compare our result with other countries maybe, and hopefully see that the consumption dropped down and that everything is fine. And yeah, actually we can see a decrease in the consumption in fattening farms. And it is our aim now to evaluate what are the reasons for this decrease, what happened here. And we had a suspicion that this has something to do with the implementation of a vaccination. And indeed, a colleague of mine evaluated that this decrease was significantly correlated to the implementation of the PCV2 vaccination in 2008. What we see further is that we have a very low usage in ferret-to-finish farms, and this gives us again space for interpretation. We have a lot of outliers and in general a high variation, and especially I want to show this one. This was constantly the same farm over the 3 years. It was a breeding farm holding around 1,600 sows, which is for Austria a very, very big farm. And yeah, it would have been very interesting to evaluate the correlation between the farm size and antimicrobial consumption, but we couldn't do that because unfortunately the sample size was too small. But in order to avoid this, that there can be farms who use so many antibiotics and much more antibiotics than other farms, we should think about, from a political point of view, implement a benchmarking system like it is already the case in a lot of other countries. So we looked at the substances that were used, and as you can see, in ferret-to-finish farms, oxytetracycline, colistin, lincosamides in combination and amoxicillin were used, while in fattening farms, the main part were lincosamides in combination. And I think that this stresses the need for implementing recommendations concerning rather using narrow-spectrum antibiotics, which has already been done in a lot of guidelines, also in the Commission's guidelines. Actually, this substance is tylosin, and according to the WHO, this is a highest priority critically important antimicrobial. And this leads me to my next slide. We heard already today about these substances, the macrolides, fluoroquinolones, cephalosporins of third and fourth generation, and the glycopeptides. And this was the result concerning the use of these substances. They were used at extents from 9 to 22%, depending on the unit of measurement. We have milligram per kilogram and number of product-related daily doses. And I want to show you this high range between these two measurement units, because I think it's very important to evaluate and to interpret antimicrobial use in number of daily doses, because it describes the treatment frequency. So where is the support again in this slide? Concerning the use of highest priority critically important antimicrobials, we must look what are the indications for their usage, and think about how can we find, maybe together with practical veterinarians, how can we find alternatives, and how can we again adapt the regulations. We took also into account the indications, as I told you, and what we see here in blue is all prophylactic use. So the highest proportion of indications wasn't related to a concrete diagnosis, but to prophylactic use, and this is of course not in line with prudent use. And I find that here in this case we must change the regulations. Concerning all the other indications, we can determine what could be alternatives. How can we maybe implement some prevention measures for reducing antimicrobial use? The dosage accuracy is also very interesting. We can only evaluate that when we have usage level data. And when we calculate a ratio between the used daily dose and the animal daily dose, we get a factor which we can categorize into correct dosage, overdosage, and underdosage, and that's the color belonging to that legend. And we can see that in this project, in parenteral administration form, the treatments were mostly correct dosed and overdosed, while we have a problem in oral dosage. We have 75% of underdosage, and this is again not in line with prudent use of antimicrobials, and we have to consider the reasons for these underdosages, and we must also think about how we can again avoid this. So I would like to come to my conclusion, and I was asked to separate it a little bit for support for scientifics and for politics. So the support for scientifics, for researchers, is that when we have data at the species level, we can use indicators, number of daily doses, and express then the treatment frequency. And I recently participated in a workshop in Ghent in June, where some experts out of Europe came together to discuss about that topic, and this was the result, that we can express the treatment frequency in % of days an animal is treated during its lifespan, or % of animals treated per day, because it is actually a very easy way and everybody can get an idea very quickly. When we have data at the farm level, we can consider farm-associated factors influencing antimicrobial consumption, like the system I showed you that Finnish farms had much lower antibiotic usage, implementation of vaccination, like it was the case in fattening farms, the farm size, and so on. We can then look what substances are used. Are they maybe critically important antimicrobials and what could be alternatives. If we have then the information at an usage level, we have the information about the treatment indication, and we can think about where can we potentially reduce antibiotic use. And as I showed you, we can look if the dosage was accurate, and as you all know, this is also very interesting for making the link to antimicrobial resistance, because a subtherapeutic dosage can also positively influence the spread of antimicrobial resistance. This is the whole idea behind it, to collect data on antimicrobial consumption, that we want to link it to antimicrobial resistance. The conclusions for politicians is that we finally know facts instead of that we make assumptions, like, for example, the debate about the guilt of antimicrobial resistance. Human doctors say, veterinarians are guilty because they use so many antibiotics, and a few years ago we weren't even able to debate that because we didn't have the data, and now we can show them the GIACRA report and say, well, look, in a lot of countries humans consume more antibiotics than animals related to the biomass. We cannot improve a situation without assessing it. We can otherwise not know that it is going better. We can set key priorities, like, for example, prohibiting prophylactic use. We can compare our data with other countries, make time trend analysis, think about implementing a benchmarking system, discuss about dispensing rights, and so on. And I would like to conclude, to finish with that picture my father likes to draw, and he drew it especially for this conference. And I think it fits into the motto of that conference, that if we have a data collection system, it means a lot of work and a lot of a great collaboration between a lot of players, especially between the veterinarian and the farmer. Thank you very much.
Many thanks to both speakers. The first one showing us the importance and the application of rapid tests in order to target antibiotic therapies, and the second one, the importance of collection of accurate data in order to identify possible risk factors for the development and spread of antimicrobial resistance and to consider possible actions. We have been given 5 minutes for discussion, and I would like to ask the audience for any comments or questions to one or the second presentation, to the first or the second presentation. Yes, Federico.
Thank you. Sorry. One short remark and one question to the last speaker. The suggestion is, you were saying that perhaps you could look at, or you were looking at the percentage of animals treated per day. Wouldn't it not be nice to turn it around and look at the animals, the percentage of animals not treated? That we much more look at the healthy animals and say, well, that's our goal, and we try to compare that. It's an easy change, but I think it's a matter of looking to farms in a different way. Then the other point, the question is, you said in relation to the farm where a lot of antimicrobials were used, the large swine farm, we could try to see if there's a relation between the size of the farm and the use of antimicrobials. But would it not be more interesting, for example, to look at not simply at the size of the farm, but for example at the number of animals under the care of one person? So maybe it's much more how much attention you can pay to the animals than the number of animals that you have together in one farm.
Yeah, thank you for that remark. You are absolutely right, especially concerning the farm size and the relation to antimicrobial consumption, there are a lot of different studies telling different results. Sometimes you can read in some papers that there is a positive correlation, but a lot of studies actually found a negative correlation. So it could also be that there's just no impact regarding the farm size on the antibiotic use. So that's why I also think that there are a lot of other factors influencing antibiotic use, and that the farm size maybe doesn't have any effect. And it would be very interesting, as you said, to evaluate whether the number of farms per farmer, per person would be interesting to evaluate, but also a lot of other factors.
Yes, please.
Hello, I'm Lina Cavaco. I'm a veterinarian as well, but I work at the EU reference laboratory for antimicrobial resistance, and I feel it's very nice to have this conference where veterinarians and farmers and the laboratories are coming together, and it's a pleasure to see that all these aspects are taken into account with the vet and farm relationship and the management and the prevention and as such. Then I have a little a question regarding the laboratory work. We do have monitoring ongoing on the zoonotic pathogens, and every member state has the laboratories that are national reference labs that are equipped and trained and have been doing monitoring and resistance for quite a long time. They would be quite important also in national levels to bring the veterinary side. Many of them are vets actually as well. Regarding the presentation on the support tools on the lab part, now there has been a lot of evolution of the methods, and MALDI-TOF is really bringing down the identification time. We also have quite a few new developments on the sequencing part, where a strain can be sequenced and ID, resistance pattern, and virulence can be taken from there in a short period of time. So, but it was mainly.
Thank you very much.
Oui, merci pour vos commentaires.
Yes, thank you for those comments. Well, this is something that we are working on. The problem with the labs on the ground, and that's who I'm representing, it's the problem of the diagnosis costs. So, when it comes to research and the reference labs, well, this is technology that's being used there, but it's difficult for us to use that kind of technology. We have to balance out what the benefit is against the cost of it.
Thank you. And we have time for one last question. It was the gentleman standing, please.
Well, we're talking about the use of antibiotics and the risk that AMR may develop and the risk to humans there. Now here we have the question about reserve antibiotics or the critical important antibiotics. They play a key role here. In the past we had a symposium held by the National Risk Assessment Body, and it was noted there that the only groups of antibiotics which really represent a risk here are fluorochilones and the second and third generation kinds of antibiotics. Now, I just want to know what sort of scientific backup you have for those statements.
Answer in English or in German. I took the definition for highest priority critically important antimicrobial from the WHO. And in this definition they are included because according to them they select for resistant Campylobacter, and the problem is that in children, Campylobacter infections cannot be treated with fluoroquinolones. And that's why the macrolides are important according to the WHO. But yeah, according to the definition or to the ranking of antibiotics from the Commission or from the OEE, they are not included. Yeah, but I took this other definition.
Merci beaucoup pour les...
Thank you very much for that final comment. So the organisers would just like to thank the speakers who took the floor this morning and who made some very interesting presentations. And I'd like to ask the three other speakers who spoke this morning to come and join me here at the top table before we move to the lunch break. And I'd also like to tell you that the presentations which were made this morning will be uploaded onto the FESASS website and the Presidency website, so you will be able to consult those next week. The conference has also been recorded, so you can watch the conference online, and we'll try to upload that over the next few days. So it will be on the Presidency website and on the FESASS website. So this brings us to the lunch break, and I'd like to ask you to come back for 2:15 at the latest.